Additive manufacturing makes it possible to produce a functional component layer for layer from a dataset of a 3D model. Additive manufacturing allows me to produce individual parts or series inexpensively and directly from the 3D model, and this means that a prototype is ready much more quickly. I can create individual large series, I am able to integrate functions into a component, and I can also produce more complex geometries, which I am not able to do in the conventional production process. The difference between additive manufacturing and 3D printing is that additive manufacturing is mainly used in the industrial sector. Why? Because we can assign certain qualitative characteristics to the components we manufacture. That means a certain strength and certain dimensions, and we also have the ability to manufacture functional components that we can subsequently use, insert and test immediately. It is therefore possible to start series production much more quickly, for example. Generally, we see additive manufacturing in our business sector, the plastics industry, because there is great demand for prototypes, individual parts and small series. However, we envisage new markets for individual products in medicine technology and even implant manufacturing, where a lot is going to be happening in the future. The idea was born more than a decade ago. We observed the market very carefully, which is what we do all of the time anyway, and soon found out that market requirements are changing continually. Product life cycles become shorter. There are more and more different model variations, which means that several different models of a component are required. There is also a strong demand for individuality, and Arborg took a look at this, put some thought into how to manufacture individual parts or small batch sizes inexpensively, and this led to development of a completely new process based on the know-how that we had gained as machine builders. The Arborg plastic freeforming uses the components and know-how that we also use in our injection molding machines, either in the freeformer technology or Arborg plastic freeforming. When we presented the freeformer in 2013, it was very well received, and we were flooded with inquiries because we had developed a completely new process that allowed us to use both standard granulates and qualified granulates. The freeformer is also an open system, which means we took a new approach that departed from the already known philosophy of current production machines. Our process is based on the decision to implement our own expertise as manufacturers of injection molding machines. This includes how plastic granulate is processed, how it is melted, and we already know how to do this, so we took the process and changed it accordingly. For example, a rotating screw melts the granulate that is kept under pressure and discharged as droplets using a piezo actuator and membrane, resulting in a very homogeneous layer, and this allows us to create functional components very quickly. The freeforming process is the only process in the additive manufacturing field that does not depend on the material, and this means you can really use qualified standard granulates. Customers can even use granulates that they have developed themselves, and this is the meaning behind the open system. Customers can adapt the process to their individual needs and components, and this allows great flexibility. Furthermore, it is a very clean process, does not need additional equipment such as extractors, etc. It is a so-called plug-and-play solution. Only electricity is required and the ability to operate the machine. Basically, the machine can be broken down to three main parts. First of all, plasticization is required for treating the material accordingly. In other words, melting the plastic granulate. Then there is the application or print head, which produces or discharges the droplets, and the axis system that moves back and forth synchronous to the droplet discharging. And this allows us to set up the parts and synchronize them to droplet discharge. We decided on a piezo actuator because it achieves the high dynamics that are needed for opening and closing when discharging the droplets. With a piezo actuator, we are moving in a fringe area of around 60 Hz, and currently when filling, up to 200 Hz. We know that higher dynamics are possible with a piezo actuator. The piezo is controlled by electronics that we developed ourselves. which of course can be integrated into the control cabinet of the machine. The piezo is significantly faster than other components, and that means that we are in a position to achieve a certain material discharge very quickly. And the piezo also has very high dynamics and the accuracy that we need for discharging the droplets.